Hi students, welcome back to Wisdom Academy YouTube page. In the previous video, you have learnt about graphs and how by using graphs to find the displacement from velocity time graph. Today's class, as I said you, we are going to derive the equations of motion by graphical method. So already you have seen one equation of acceleration where you found that A is equal to V minus U by T. So when you rearrange this, you will get V minus U is equal to AT and V is equal to U plus AT. This itself is an equation of motion, but definitely if you do this in the school examination, they won't accept it. So I will teach you how by using graphical method to derive this equation and other two equations. What are those equations? You are so eager to know, you will know. Within some 10 minutes you will know. Fine. So let us start deriving it. For that I am taking the help of velocity time graph. So I am drawing time on the x-axis and I am drawing velocity on the y-axis. Why I am doing this? Because I know velocity time graph gives you the area under the velocity time graph gives you displacement. Okay. Let me assume that any vehicle or any object is having some initial velocity. So initial velocity, let this be here u. So it is having some velocity and then it is moving. It is moving in such a way that it attains a higher velocity. Let this point be v. What is v? V is final velocity. I hope you know that. U is initial velocity, v is final velocity, right? So now tell me, when any object wants to accelerate and if any object wants to increase its velocity, how will it do so? By acceleration. Can you increase the velocity without acceleration? Not possible. But definitely there is some acceleration. That's why the velocity has increased from u and reached the value v, isn't it? So it is having acceleration. Since the velocity is changing, it is the example of non-uniform motion. So remember that equations of motion is always given for non-uniform motion, because if it is uniform motion, v and u will be same, and when v and u will be same, then there is no meaning of these equations. Acceleration itself will become 0, isn't it? So this equation of motion we are finding for non-uniform motion. I will repeat once again, if it is uniform motion, velocity will itself not change. When velocity will not change, then where is the quotient of acceleration? There is no acceleration. So here, since the velocity is changing, there is some acceleration. And for changing the velocity from u to v, it has taken some time on the x-axis, and let this time be t. Let this time be t. Fine. So I will repeat once again. This value is v, this value is u, this value is t, and I am going to derive the equations of motion. Right. So let me name all these points and let me name it as, let this be origin O, and I am naming it as A, B, and I am just drawing a parallel line here for easiness, C and D. So what is the graph? Graph is O, A, B, C, D, O, this whole thing, area. Okay, before starting the area about the graph, you also know that slope of a velocity time graph gives you, yes, acceleration. Please go in the previous video, you can see there. So we know that slope of VT graph gives us acceleration. So I am deriving the first equation now, the first equation of motion. So slope of VT graph gives acceleration, right? So what is the slope here? Let us see. Slope I told you y2 minus y1 by x2 minus x1. So A is equal to y2 minus y1 by x2 minus x1. So what is y2 minus y1? This minus this, isn't it? So y2 is v, this is u. So it is v minus u by, what is x2? This point t, this point 0, t minus 0. So I got v minus u by t. When you rearrange, you will get v minus u is equal to at, and therefore you get v is equal to u plus at. This is how I derive the first equation of motion. Very simple, right? What I have done, I have taken the slope of velocity time graph, and I know by my knowledge of graph that slope of vt graph gives me acceleration, and acceleration will be y2 minus y1 by x2 minus x1. These are the coordinates. This is y1, for this it is x1 here, and this is y2, for it is x2 here. So y2 minus y1 is v minus u, x2 minus x1 is t minus 0. That's why I have done this and I have got this. Can you see it is same? Right. Now I am going to second equation of motion. So for second equation of motion, what you should remember? You should remember that you have to find the area of the curve, and we know that area of the curve gives the value of displacement. So what I am writing, that area under Vt graph gives displacement. If I write displacement as S, so S will be equal to area. Which area? This complete area, O, A, B, C, D, O. O, A, B, C, D, O. I am starting at O and I am ending at O because I want to show that it is a closed figure. Okay, right. So now this area I can break into two parts, area of a triangle, area of a rectangle. So for finding the second equation of motion, remember that this area under the graph has to be broken down into two components, that is area of the triangle and area of the rectangle. So I am writing here as area of this triangle, that is ABC, plus area of the rectangle, that is OACDO. Fine. So what is the area of triangle ABC? ABC will be equal to half into base. Base is this AC into height. Height is BC. Okay, this is the first part. Plus, what is this area? This area will be OD into OA. Right. So half. What is AC? AC is T. I can write here T. What is BC? BC is this value. If this is V, this is U, will not this part be V minus U? Think, this complete thing is V, this is U, this will become V minus U. So like this is 10 centimeter, this is 4 centimeter, this will become 6, no? 10 minus 4, same way. This is V, this is U, this is V, this is U, this will be V minus U. So I can write here half T into V minus U plus OD, OD is T, OA, OA is U. Right. Now from here I will use something. Let this be equation number 1, and from equation 1 I can write, so this I have got the expression of S, but from equation 1 I know that A is equal to V minus U by T. So I can write V minus U is equal to AT, isn't it? So V minus U is equal to AT. Let this be equation number 2, and this equation 2 I will put in this equation. So I will write it here, that let me draw a line, putting equation 2, what I get? I get S is equal to, I will make this term to go in the front, that is UT plus half into T into V minus U. What is V minus U? AT. A again T will come. So I get S is equal to UT plus half AT square. This is the second equation of motion. What is S? Displacement. What is U? Initial velocity. T time. A acceleration. Right. This is how we derive the second equation of motion. Let us see the derivation of third equation of motion. So for third equation of motion, I will use the same concept. Difference is, there I took area of this complete thing as triangle plus rectangle. In the third derivation, I will take the whole area as a trapezium area itself. Right. So we know that area under VT graph gives acceleration, gives displacement, that is S. Therefore, S is equal to, same thing I am writing, area OABCDO, that is area of trapezium. What is area of trapezium? Half into sum of the opposite sides multiplied by distance between them. So, half into this OA plus BD into, what is this height? OD, right. So, half, what is OA is U, what is BD? It is V, U plus V. What is OD? OD is T, right. Now, once again I will take help of this equation. So, from equation 1, we can write A is equal to V minus U by T. So, from here I can write T is equal to V minus U by A. Let this be equation number 3. Now, I will put this value of T here. So, putting equation 3, what I get? I get S is equal to half, already V plus U was there, and I will write V minus U by A, isn't it? A plus B, A minus B, A square minus B square. So, I get here V square minus U square by 2A. So, I get S is equal to, or I will make these two things to go here, I will get 2AS is equal to V square minus U square, or I can write V square minus U square is equal to 2AS. This is the third equation of motion. So, this is the first equation of motion, this is the second equation of motion, and this is the third equation of motion. What is the first equation of motion? V is equal to U plus AT. What is the second equation of motion? S is equal to UT plus half AT square. And third equation of motion, V square minus U square is equal to 2AS. What you should remember is, V is final velocity, U is initial velocity, T is time, A is acceleration, and S is displacement. And what you should always remember is, this first thing is this thing which you should remember to find the acceleration. That slope of VT graph gives you the value of acceleration. You should remember this thing, that area under the VT graph gives the value of displacement. And you also should remember that for second derivation, I will use area 1 and area 2 separately. For third derivation, I should take the area as area of trapezium. And one more thing you should remember is how to use this equation to convert this value, convert this V minus U into AT, and here converting this T into V minus U by A. These things, if you remember, no one can stop you from getting full 5 marks when this question comes in the examination. So, sir, will this question come in examination? Definitely this question will come into exam. Whichever school in the country you belong to, if you are studying in 9th standard, they will definitely ask you in 5 marks to derive the equations of motion graphically. So, the more you better understand it, the more chances you will have to get the 5 marks. Remember that. If you are now, you will be understanding why I taught you graph with so much of difficulty, even if it is not there in syllabus, because now you are able to get the idea that slope of VT graph, area under VT graph are how much important for derivation of equations of motion. I hope you have understood this. Now, let us talk about the last concept of this chapter, that is uniform circular motion. Right. So, we have uniform motion. What is uniform motion? When the velocity of an object is not changing, it is called uniform motion. But when the velocity of the object is changing, it is called as non-uniform motion. Now, let us see what is uniform circular motion. It is little bit confusing, but I will try to make it as easy as possible. Right. So, tell me, what is velocity? I have told you velocity is speed with direction. I told you, it is a vector quantity. When any object is moving with some speed and has a direction, it is called as velocity. So, velocity I can write as, velocity can be written as speed plus direction. So when I say change in velocity, actually what is changing? Its speed is changing, isn't it? I am telling a car moving at 20 km per hour accelerates and reaches 40 km per hour. I never talk about the direction. So what has actually changed? The speed has actually changed, and that's why I say it is non-uniform motion. Is it possible that the speed does not change, but the body comes as like its velocity gets changed? I am trying to say that the speed remains same, but then also the velocity is changing. Is it possible? Yeah, it is possible if the direction changes. So suppose a body is moving with 20 km per hour from here to here, 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 here to here, like this. And in every stretch it has gone same 20 km per hour, 20 km per hour, 20 km per hour, like this. Now what has happened? The speed has not changed, but the direction is changing every time, like this, then this, then this, then this, then this. So can I say it is a uniform motion? I cannot say. It becomes a non-uniform motion. Why it becomes a non-uniform motion? Because though the speed remains same, the direction is changing, and since the direction is changing, it is a change in velocity. So in order to attain this, definitely it will be accelerated motion only. Remember this. So if you want pakka uniform motion, when you want speed to remain same but direction to keep on changing, then I can say a body to be in a circular motion, because when a body is in circular motion, at every instant the direction keeps on changing. Can you see like this? Every second you change, it is changing. Here it is not possible. Here suppose I am taking this point, this direction, this point, again this direction. So from this to this stretch it is having uniform motion. As a whole only it is on uniform motion. Are you getting what I am trying to say? From here to here it is uniform motion, but from here to here it is non-uniform motion. So every part is uniform, but combinedly it is non-uniform. But in circular motion, even if you take a nearby point, these two will have two different directions. So circular motion is a condition where even if you try to maintain the same speed, the direction will change at every instant. Direction changes at every instant. So this is uniform circular motion. So what is uniform circular motion? Motion in which a body is moving along a circular path with same speed. Sometimes they often ask in examination, is uniform circular motion an accelerated motion? What you should write? Yes, a uniform circular motion is an accelerated motion, because though the speed remains uniform, the direction keeps on changing, and when the direction keeps on changing, its velocity keeps on changing. I hope you got some clarity why I said it is a non-uniform motion. Because it is, why it is non-uniform motion? Because speed remains same, direction is changing. When direction will change, velocity will change. So it is a accelerated motion. One more thing, if you want to find the velocity, that is the speed of this motion, what will be the speed? The speed will be equal to the distance covered. Distance covered will be 2 pi r in one round, and time taken is t. So 2 pi r by t is the speed in circular motion. Speed in circular motion. Sometimes speed is also called as magnitude of velocity. It is the magnitude of velocity. Some books will also write like this, velocity magnitude, like this we represent, or we can write simply like this also. Velocity is equal to 2 pi r by t. Don't get confused there. Here it is magnitude of velocity, which is also called as speed. It is not the vector. Vector in the sense, not the vector velocity. It is only the magnitude of the velocity. So with this, I am ending today's this chapter, that is motion. And what we have learned in this chapter, from beginning we have learnt about what is motion and how a motion can be little complex. I just told you different frame of references, motion will change. I also talked about what is distance, what is displacement. I talked about what is speed, what is velocity, what is average speed, what is average velocity. I talked about what is acceleration. I have talked about the graphs we used for solving the equations of motion, and then I have derived all the 3 equations of motion graphically. So with this, I am ending up today's session. In the next video, I will be solving many numericals based upon this chapter, which will help you to understand it more better way. So please see the videos completely, like the video, subscribe the channel and share with your friends. Thank you.